Welcome to my presentation on exploring the relationship between various population indicators and depression prevalence or rates across countries. My name is Darwin Gomez, and let's get started. Depression is a serious mental illness that affects people worldwide. The study extends my Data606 project, where I aim to identify and understand various population indicators that may have a significant relationship with a country's depression rates or prevalence among its population. My null hypothesis for this study is hypothesis zero. There is no explanatory relationship between alcohol consumption and other population indicators such as undernourishment, access to clean water, unemployment rate, and public spending on education, and the depression prevalence rate in a country's population. The alternative hypothesis is that there is a significant relationship between these variables and the depression prevalence rate across countries. For this study, our cases are countries, and there are 80 of them. The study is observational. The response variable is depression prevalence, which I'll sometimes refer to as rate. And the explanatory variables are alcohol consumption total, which is a percentage of the population as expressed by the GDP, and then prevalence of undernourishment, a percentage of population, people using safely managed drinking water services as a percentage of population, unemployment rate as a percentage of the total labor force, and the public spending on education as a percentage of GDP. In this data set, I put together three different data sources to combine the data and the variables that I needed. The first data set that I got is depression rates by country 2024. This data set contains country level data on the prevalence of depression as a percentage of its population and also the absolute number of cases for the year 2024. We'll only be using depression rates by country or prevalence, which is later transmuted to depression prevalence. The second set is population indicators from the World Bank data 2020. And this dataset contains percentage of countries' populations across public indicators. It was pulled from multiple reports on World Bank data into a CPS format. And the popular variables that I'll use here are prevalence of undernourishment as a percentage of the population, people using safely managed drinking water service, unemployment rate, and public spending on education. And the last data set that we'll be using is alcohol consumption by country 2020. And this data set provides country level data on per capita alcohol consumption or liters of pure alcohol for both sexes, but we'll only be dealing with alcohol consumption of the total population, combining both sexes. So because the data is all coming from different sites, I had to import them separately, do some data cleaning on them, and then join them into one cohesive data set. This is what this data set looks like after all the cleaning and joining. And I'm left with 80 countries, which is much less than I had in my previous study where I had 165 countries. But many of these countries just didn't have the population data. They don't invest in that infrastructure, and so I'm only using observations that don't have missing data because I want to be able to explore all variables. Some of my wrangling involved turning character columns into numerics, um, changing column names into something that I could work with easier. I wanted to get rid of white spaces. Um, I didn't have to scale or center my data because for the most part it was already done. As part of my EAD, I always like to visualize my variables if they're numeric and get a distribution for them. And so I'm just going to be showing the plots here. We have distribution of alcohol consumption in countries, and on the right we have distribution of depression prevalence in countries. Here on the left we have public spending on education. That looks a little normal to us, and then as you can see, a lot of these other ones are definitely not normal distributions. Sort of like this undernourishment prevalence in countries. Then here we have the distribution of population for unemployment and the distribution of percentage using safe drinking water. I decided to run a Shapiro-Wilk test on these just to see um, which ones were representative of a normal distribution and which ones were not. The only two that were normally distributed are depression prevalence and public spending on education. The other four do not meet the requirements. So I mentioned that I had done a previous study, and in that study I had done a simple linear model trying to use alcohol consumption as an explanatory variable to determine depression prevalence. This was that model, and as you can see, the model wasn't um, too robust. It did um, it did give us a significant relationship and a slight positive slope between the two variables, but with an R squared of 0.0481, we were really only predicting about 4 4.8% of the variance in the depression statistic. And this is those two the, this is those two variables plotted against each other, and the model fitted. The linear regression line fitted across it. Now, since many of my variables were not normally distributed, I decided to do a Spearman correlation test, which doesn't assume normality between the two variables. And what we get back with this is coefficient rho, um, which indicates a correlation between the two variables. So alcohol consumption total has a slight positive correlation with depression prevalence. Um, this one is odd here, row one, with prevalence of undernourishment of population. It suggests that as the population is more malnourished, that they're less depressed, and that is something that doesn't really make sense to me. Other than the only thing I could think of is that the people responsible for reporting data either don't have sufficient data from from their citizens, or they are not reporting that data accurately. Um, then people using having safe drinking water has a much higher correlation and is very significant. Unemployment, the unemployment rate of the labor force has a slight correlation and is also significant. And then public spending on education has a slightly higher correlation with also a very significant um, relationship. So they all have independently significant relationships with um, with depression prevalence um, as a result of the Spearman correlation test. So as part of my limitations in my conclusions for my last study, where I fitted a simple variable to variable regression model. Um, I proposed that maybe finding more predictors to go along with alcohol consumption would result in a better linear model for or linear regression model. And so that was the inspiration on combining some more data sets for this study. And so what I did was I fitted a new linear model for depression prevalence using the five other variables here. And I did get a better R squared. Here I'm having an adjusted R square of 0.4217 and an F statistic of 12.52 on 74 degrees of freedom and a p-value. Uh, Very significant. Got to be, you know, 9 zeros before that 8. So very, very small, much smaller than the threshold of 0.05. And so what this is telling me is that, we are accounting for 42% of the variance in depression prevalence, but there's still about 58% that we're not. So there's still predictors that I haven't identified that would probably benefit in this model. Um, some of those would be off the top of my head probably like total GDP, maybe education levels, things that allow people to feel a little more accomplished in their lives, maybe religious freedoms, things like that. I also wanted to do some validation. So I did some tenfold validation here on the linear model, and with the tenfold validation, we did get slightly improved stats. We actually jumped our R squared by 10%. So there is room for improvement in this model, and that kind of shows that maybe with more data points, um, we can uh, we can predict more of the variance. Here I'm showing some of the diagnostic plots for the model. On the left, we got the residual distribution, which is actually pretty damn near normal. I was surprised to see it so nice and neat. Um, the QQ plot has some slight deviations, especially around the one quantile on the theoretic quantile, where it starts to deviate a little bit from our QQ line, but not anything too drastic. And then on the bottom there, the residuals versus fitted values. We can see that they're kind of like randomly distributed between both above and below zero, which is good. But we could also see that there isn't really constant variance. So some of these residuals are changing a little bit, and um, kind of like we would expect, right? Some of our variables were not normally distributed. That kind of sticks out here. So our updated analysis summary. In our initial analysis, both the Spearman correlation, because I did Spearman correlation there too, our rho was a 0.2290. So also indicating a weak relationship between alcohol and the depression prevalence then. And then our linear regression slope of 0.04 also indicated a weak positive relationship between alcohol consumption and depression prevalence. Both of those tests had significant statistical importance, with p-values far below 0.05 threshold. And the R squared of that model, like I said earlier, left us wanting a lot more, with only 4.81% of the variability in depression prevalence being accounted for. So in our new findings, we added four new variables: prevalence of undernourishment, people using safely managed drinking water, unemployment rate, and the public spending on education. Together with alcohol consumption, this gave us five features to use with our model, and the R squared of the cross-validated model came in at 52 at 0.5289, which explains nearly 53% of the variance, with an RMSE of 0.4828. And there was a very significant predictor, which was people using safely managed drinking water. And this predictor shows a strong and statistically significant positive relationship with depression prevalence. But I do have to say is that there was a decrease in the significance of alcohol consumption. While it was very significant in my previous study, in this study, that was no longer the case. Um, and the only, one of the reasons I feel that that's possible is that the big reduction in the sample size. So I went from 165 cases to 80 cases because while I had 165 cases with alcohol data and depression data, I only had 80 cases where I had the data for all the variables that I was looking for. And so I think that cutting that sample size by so much, also some of the countries that were there, like I think I had Russia there and Ukraine, which aren't in this study, it's a little it took away from the importance that alcohol consumption had on depression prevalence based on that study. And then, so in conclusion, we're going to reject the null hypothesis of and just as a reminder, the null hypothesis was that there is no explanatory relationship between alcohol consumption other indicators and depression prevalence. And given the results of both the multiple linear regression model, which found at least one significant predictor of people having access to safely managed drinking water, and also from our Spearman correlations, we have to reject the null hypothesis because our p-value was indicated a strong relationship there. And so while alcohol consumption is no longer a significant predictor in this iteration of my study, the presence of other significant predictors indicates that there is a significant relationship between this combined set of predictors and the depression prevalence across countries' populations. And that brings me to the end. So thank you guys. I hope you guys have a great break.